तुम्ही अजूनही चॅनलला सबस्क्राईब केलं नसेल तर चॅनलला सबस्क्राईब करा आणि साईडला दिलेल्या बेल आयकनला प्रेस करा. ओके, सो टुडे वी आर टेकिंग अ क्लास 10 सायन्स चॅप्टर नंबर 1 that is a gravitation exercise question and answers. Okay, let's start. See the question number 1. Study the entries in the following table and rewrite them putting the connected items in the single row. Okay, see the answers of that chart. Mass is measured in kilogram and measure of inertia. Weight, it's measured in Newton, depends on the height. Acceleration due to gravity, it's a meter per second square. 0 at the center of the earth. Gravitational constants is Newton meter square per kg square. Same in the entire universe. Okay, see the question number 2. Answer the following questions. In that question A, what is the difference between mass and weight of an object? Will the mass and weight of an object on the earth be the same as their values on Mars? Why? Answer. The mass of an object is the amount of matter present in it. It is same everywhere in the universe and is never zero. It is a scalar quantity and its SI unit is kg. The weight of an object is the force which the earth or other planet, moon, star attract it. It is directed towards the center of the earth. The weight of an object is different at different places on the earth. It is 0 at the earth's center. It is a vector quantity and its SI unit is a Newton. The magnitude of the weight is the mg. The mass of an object will be the same on the earth and Mars, but the weight will not be the same because value of g on Mars is different from that on the earth. Question number B. What are the free fall, acceleration due to gravity, escape velocity and centrifugal force? Answer. What is meant by free fall? Whenever an object moves under the influence of the force of gravity alone, it is said to be free, falling freely. Okay. Second is acceleration due to gravity. The acceleration produced in the body due to the gravitational force of the earth is called as acceleration due to gravity. Third is escape velocity. When a body is thrown vertically upward from the surface of the earth, the minimum initial velocity of the body for which the body is able to overcome the downward pull by the earth and can escape the earth forever is called as escape velocity. Fourth point, centripetal force. The uniform circular motion of the body. The force acting on the body is directed towards the center of the circle. This is called as a centripetal force. Question number 3. Write the 3 laws given by the Kepler. How did they help the Newton to arrive at the inverse square law of gravity? Kepler's first law. The orbit of the planet is an ellipse with the sun at the one of the loci. See the diagram of the Kepler's first law. After that, Kepler's second law. The line joining the planet and the sun sweeps equal areas in equal intervals of time. A to B, C to D and E to F are the displacements of the planet is equal intervals of time. The straight line AS, CS and ES sweep equal areas in equal intervals of time. Area ASB is equal to area CSD is equal to area ESF. Okay. Kepler's third law. The square of the period of the revolution of the planet around the sun is directly proportional to the cube of the mean of distance of the planet from the sun. Thus, if the r is the average distance from the planet from the sun and t its period of a revolution, then t square is directly proportional to the small r square. That is, t2 r3 is equal to constant, which is equal to k. For simplicity, we shall assume the orbit to be a circle. In that, this S, see that S denotes the position of the sun, P denotes the position of the planet at the given instant, and R denotes the radius of the orbit, which is equal to the distance of the planet from the sun. Here the speed of the planet is uniform. Here the speed of the planet is uniform. So velocity is equal to the circumference of the circle divided by the period of revolution of planet. That is, circumference of the circle is 2 pi r divided by time period, that is a t. If the m is the mass of the planet, the centripetal force exerted on the planet by the sun is equal to the mv square by r. What is the value of m? That is a 2 pi r by t square divided by r, which is equal to 4 pi r square, 4 pi m r square upon t square into r, which is equal to 4 pi square m r upon t square. According to the Kepler's third law, t square is equal to k r cube. F is equal to force is equal to 4 pi square m r upon k r cube, which is equal to 4 pi square m upon k 1 by r square. Thus, force is directly proportional to the 1r2 as 4 pi square mk is the constant in a particular case. D. A stone thrown vertically upwards with the initial velocity u reaches a height h before coming down. Show that the time take to go up is the same time taken to come down. Okay, see the diagram. Here is a point, here is a b point. After that, here is a b point and here is a point. Time taken is the t1 and t2. The stone moves upward. B to A, the stone moves the downward. A to B, the stone moves the upward. Okay. We have V is equal to U plus AT, equation number first, and S is equal to UT plus 12 AT square. Okay. Therefore, S is equal to V minus AT T plus 12 AT square, which is equal to Vt plus AT square plus 12 AT square. S is equal to Vt minus 12 AT square, equation number 3. As the stones move upward from A to B, S is equal to AB, which is equal to H, T is equal to T1. A is equal to minus G, retardation, U is equal to U and V is equal to 0. S is equal to AB, which is equal to H, T is equal to T1. A is equal to minus G, that is a retardation, U is equal to U and V is equal to 0. From equation number 3, height is equal to 0 minus 12 minus G T1, okay, square, and therefore height is equal to 12 G T1 square. As the stone move downward from the B to A, T is equal to T2, mu is equal to 0, S is equal to H and A is equal to G. From equation number 2, H is equal to 12 GT square, okay. From equation number 4 and 5, T1 square is equal to T2 square and therefore T1 is equal to T2. R positive. Question number E. If the value of the G suddenly becomes twice its value, it will become 2 times more difficult to pull a heavy object along the floor. Why? Answer. To pull an object along the floor, it is necessary to work against the force of friction between the object and the surface of the floor. This force of friction is proportional to the weight mg of the object. If the value of the G becomes twice its value, the weight of the object, and hence the force of friction will become a double. Therefore, it will become 2 times more difficult to pull a heavy object along the floor. Question number 3. Explain why the value of the G is 0 at the center of the earth. The value of the G changes while going deep inside the earth. It goes on the decreasing as we go from the earth's surface towards the earth's center. We shall treat the earth as a sphere of uniform density if we consider a particle of mass m at point P at a distance r minus d from the earth's center, where r is the radius of the earth and d is the depth below the earth's surface. The gravitational force on the particle due to the earth is force is equal to gmm r minus d2, where m is the mass of the sphere and r radius r minus d. Capital M is equal to 4 by 3 pi r minus d चा cube multiplied by capital M divided by 4 by 3 pi r cube, which is equal to capital M r minus d cube upon r cube. Because outer spherical shell is not effective, in this case the acceleration due to gravity is g is equal to force upon mass, which is equal to g capital G upon r minus d चा स्क्वेअर कॅपिटल M r minus d चा क्यूब अपॉन r क्यूब which is equal to gm r minus d upon r cube, where capital M is the mass of the earth, thus g decreases as d increases. It is less than that at the earth surface. Gm r square at the earth center, d is equal to r, therefore g is equal to 0. Question number 4. Let the period of revolution of the planet at the distance r from the star be capital T. Prove that if V was at the distance of twice r from the star, its period of revolution will be 8 minus root T. Answer: capital T is equal to 2 pi g m root r cube by 2, where T is equal to period of revolution of planet around the sun, m is the mass of the sun, g is the gravitational constant, and r is the radius of the orbit assumed to be circular, which is equal to distance of the planet from the sun. For r is equal to capital R, T is equal to T1. Okay, T1 is equal to 2 pi root capital Gm r 3 by r raised to 3 by 2. For r is equal to 2r, T is equal to T2. T2 is equal to twice pi upon root capital Gm in bracket twice r raised to 3 by 2, which is equal to 2 pi upon root capital Gm r raised to 3 by 2 and 2 raised to 3 by 2, which is equal to T1 2 raised to 3 by 2. Therefore, T2 is equal to T1 root 8, which is equal to root 8T. Okay. Question number 5. Solve the following examples. In that first, an object takes a 5 as to reach the ground from the height of the 5 meter on a planet. What is the value of the g on the planet? Solution. Data: u is equal to 0 meter per second, displacement is equal to 5 meter, and time is equal to 5 seconds. G is equal to what? Displacement s is equal to 1 half gt square, 5 meter is equal to 1 half g into 5s square, which is equal to 1 half g into 5s and 5s. Okay. Therefore, g is equal to 2 by 5 meter per second square, which is equal to 0.4 meter per second square on the planet. Question number B. The radius of the planet A is the half the radius of the planet B. If the mass of A is the ma, what must be the mass of B so that value of the g on the B half that of its value of A? Solution. Data: Ra is equal to the Rb divided by 2, Gb is equal to 12 Ga, and we have to calculate the Mb. G is equal to capital Gm or capital M upon R square. Therefore, Ga is equal to Gma upon R2 Ra square, and Gb is equal to Gmb upon Rb square. So, Gb upon Ga is equal to Mb upon Ma and Ra upon Rb चा square. Okay. So, therefore, 1 half is equal to Ma upon Mb upon Ma, 1 half चा square, which is equal to 1/4 Mb upon Ma. Therefore, Mb upon Ma is equal to 4 by 2, which is equal to 2. So, Mb is equal to twice Ma. Last एवढी आता एक बाक. Question number C. The mass and the weight of an object on the earth are 5 kg and 49 Newton respectively. What will be their values on the moon? Assume that the acceleration due to gravity on the moon is 1/6 of that on the earth. Solution. Data: mass is equal to 5 kg, weight is equal to 49 Newton. So, Gm is equal to Ge on the moon, mass on the moon. Okay, we have to calculate the mass on the moon and weight on the moon. Okay, so first point in the mass of the object on the moon, which is equal to the mass of object on the earth, which is equal to 5 kg. Second point, weight is equal to mg, that is a weight on moon upon weight on earth, which is equal to mg on moon and mg on earth, that is a which is equal to gravity on moon upon gravity on earth, which is equal to 1 by 6. So, weight on moon, which is equal to the weight on earth upon 6, which is equal to 49 Newton divided by 6. The answer is 8.167 Newton, weight of the object on the moon. Question number D. An object thrown vertically upward reaches the height 500 meter. What was the initial velocity? How long will the object take to come back to the earth? Assume gravity is equal to 10 meter per second square. Solution: 100 meter per second square and the 20 seconds. A ball falls off a table and reaches the ground in 1 second. Assuming the g is equal to 10 meter per second square, calculate its speed on the reaching the ground and the height of the table. Okay, so solution is: data is given, time is equal to 1 second, gravity is equal to 10 meter per second square, and mu is equal to initial velocity is 0 meter per second, and acceleration we have to calculate acceleration and velocity. So first point is, we have equation s is equal to ut plus 12 gt square. So 12 gt square, for 12 gt square the u is equal to 0 meter per second. So s is equal to 12 into 12 meter per second square and 1 second square, which is equal to 5 meter. The height of the table is equal to 5 meter. So equation we have given here for second calculation, v is equal to u plus at, which is equal to u plus gt. So 0 meter per second plus 10 meter per second square into 1, so which is equal to 10 meter per second. The velocity of the ball on reaching the ground is 10 meter per second. F. The mass of the earth and the moon are 6 into 10 to the power 24 kg and 7.4 into 10 to the power 22 kg respectively. The distance between them is 3.84 into 10 to the power 5 km. Calculate the gravitational force of attraction between the two. Use the g is equal to 6.7 into 10 to the power 11 Newton meter square kg square. Okay, so solution is: data we have given, m1 is equal to 6 into 10 to the power 24 kg, m2 is equal to 7.4 into 10 to the power 22 kg, r is equal to 3.84 into 10 to the power 5 km, and the 3.84 into 10 to the power 8 meter. Convert the kilometer into meter. So g is equal to 6.7 into 10 to the power minus 11 Newton meter square kg square. We have to calculate force. We know that the formula, force is equal to g m1 m2 upon r square. So put the values of that and we getting the answer here, 2.017 into 10 to the power 20 Newton. This is the magnitude of the gravitational force between the earth and the moon. Question number G. The mass of the earth is the 6 into 10 to the power 24 kg. The distance between the earth and the sun is the 1.5 into 10 to the power 11 meter. If the gravitational force between the two is the 3.5 into 10 to the power 22 Newton, what is the mass of the sun? Okay, we have given here g is equal to 6.7 into 10 to the power minus 11 Newton meter square kg square. So data have given, m1 is equal to 6 into 10 to the power 24 kg, r is equal to 1.5 into 10 to the power 11 meter, and f is equal to 3.5 into 10 to the power 22 Newton. So g is equal to 6.7 into 10 to the power minus 11 Newton meter square kg square. So we have to calculate the m2. So we know the formula, force is equal to g m1 m2 upon r square. Just rearrange the formula, m2 is equal to fr square upon g m1. So put out the values, we getting the answer 1.96 into 10 to the power 30 kg. Okay. So last question is for project. Please read that question and if okay, just read the question of the project. Take a weights of the 5 of your friends. Find out what their weights will be on the moon and the Mars. Answer is: help. The weight of the body on the earth is W1, that is a mg1. On the moon, W2, that is a mg2. On the Mars, that is W3, it is a mg3. So W2 is equal to W1 into G2 and G1, and W3 is equal to W1 into G3 and G1. Now G1 is equal to 9.88 meter per second square, G2 is equal to 1.67 meter per second square, and G3 is equal to 3.72 meter per second square. If W1 is equal to 500 Newton, then W2 is equal to 500 Newton into 1.679 into 81 Newton, and which is equal to 85 into 12 Newton. approximately, and W3 is equal to 500 into 3.7 to 9.81 Newton, which is equal to 189.6 Newton. So thank you students, please like, share and subscribe the channel.